This is Greg Trotwine with Maritime Reporter TV, and we're very pleased to be joined today by Stefan Gallard, Grain to Sail, to discuss this company and its growing fleet of wind-powered cargo vessels. Can you give us a by the numbers look at Grain to Sail today? And again, I'm looking for numbers that convey the size, shape of your operation using the metrics of your choice.
Sure. So we're still a small business, realistically, but that is probably also why we were the first ones to launch a marine merchant cargo vessel powered by the wind exclusively, because we were able to combine a land-based business with a water-based or ocean-based business. And so our business today is about 70 employees. And that includes the food or the food business as well as the shipping business. And we're a company that'll hit probably about 14 million euros in revenue in 2024. And we have two ships. We have two production facilities in France, and we distribute in France in general grocery retailers, as well as now export some of our finished products to the US market. So our chocolate bars are actually available on the East Coast and all the way to California with distributors that we have there. So it's a small business, but kind of far-reaching and complex because we're working on different business models as well. And what's unique is sort of integrating them vertically, where at least initially we were our own client. So we were the cargo owner as well as the ship owning company. And that's what's helped us kind of build out the business, but it is rather unique.
I know you've discussed it, but can you take me back to the beginning? What was the genesis of Grain to Sail to be created, and what specifically is your business model?
So the company was founded by two twin brothers who themselves had prior experience developing different companies. So they were entrepreneurs in the renewable energy sector. So they particularly worked on wind farms onshore and offshore. And so it was with the offshore wind farm business that they really became passionate about the power of the wind and what could be done with it. So the original premise was to try to utilize wind as a way to reduce the carbon footprint of shipping. But in order to do that, the very first question you're going to have to ask yourself is, how do we finance this? And it's almost the same question, but what are we going to put in the boat? And one of the limitations of having a wind-propelled ship, which is starting to change, but at the time, we're talking about 10 years ago, 10, 12 years ago, wind had the major limitation of having smaller boats. So you couldn't do wind propulsion at a large scale. And so the kind of genius of the two brothers was to say, well, if we can't be competitive on the economic side and convince cargo owners to work with us in a traditional kind of freight business model, then the way for us to accomplish this is to become our own client. And so we're going to build out the food business first as a way to finance the maritime business. And by virtue of having production needs, we will generate transportation needs. And so that's how we started the business. So we had initially a relatively small boat, but it was enough to get things going. And two things happened. One was it really got people interested and excited about what we were doing. And because our products were also objectively good, people started buying. And so that kind of helped build out the financial capabilities of the company. But as we were actually sailing and crossing the Atlantic, customers, or I should say prospects at that point, started calling and saying, hey, could we do this with you guys? Could we transport? And that wasn't initially really part of the equation because we didn't see a real viable business model. And the way to make that more viable was to actually increase the size of the ship. So we went from a first ship in 2020, which was relatively small, to a much larger ship in 2024 that was just launched earlier this year. And so that now has enabled us to become a freight forwarding company and therefore provide transportation services for external clients.
I know you just talked about the fleet as it exists today. You have two vessels. We'll get into the technical specs of those a little bit later. I understand that you also have a third being built, or in the design phase to be built. So can you just, I guess, more holistically discuss the to sail fleet as it is today, what's being built and where, and what's your projection for growth in the coming 5 to 10 years?
Yeah, so some of the few things we've learned, and this is sort of an industrial approach where you start small with a prototype, then you start scaling it up until you reach kind of massive scale. And that's kind of what we're doing out progressively. As a quick reminder, the wind-propelled maritime segment of the international supply chain is still a very, very small and emerging business. So it wasn't realistic to go full scale right from the beginning. So that's also why we've built it out that way. And so we have one first ship that was or that is a 72 footer, 24 meters, and transportation by the pallet up to 50 tons of payload capacity on board. The second ship is a 52 meter, so with a payload capacity of 350 tons. And what's interesting is you more than double the length in this case, but you double the length and you double the width and you also double the height. So your volume is almost 2 by 2 by 2. So you're almost multiplying by 8. So we went from 50 to 350 tons. So it's not quite by 8, but that's sort of the ratio to give an idea. We're doing transportation by the pallet. And one of the key things that we've heard from clients is that our cost of transportation is still relatively high. We're talking about 2 to 5 times more than what it would cost on a traditional kind of conventional cargo ship on transatlantic routes. And so the biggest challenge for us was how can we increase the scale of these ships while remaining true, and this is our core philosophy, to a pure sailing approach. So both of our vessels are pure sailing vessels. So other than a small engine to maneuver in and out of the ports, we're operating by wind only. And so we have about 2 to 3 days of diesel fuel on board just for backup purposes in case everything really went bad. But needless to say that with 2 or 3 days, that's completely insufficient to cross the Atlantic. So you better learn how to sail if you're wanting to use our ships. So the advantage of that is that it drastically reduces the carbon footprint. So we're able to reach 90% plus decarbonization rate on the KPI that is usually used, which is CO2 emitted by ton transported by kilometer traveled. And so we're doing a really good job with that. And as I mentioned earlier, the limitation was and still is to an extent scale for wind. So how do you increase the size of the ships? And obviously the financial equation is directly linked to the length or to the payload capacity on board. The more you can load, the more efficient you are economically. And so two things happened. So we understood that, and that was a desire from our clients as well, bring the cost down. And on the technology front, what's happened is that equipment manufacturers are innovating with masts and rigging systems. So we'll be the first ones to implement with Grain to Sail 3, the next ship, which is 110 meter long. That is it's in the final phases of design and scheduled to be launched in 2027. And that ship will be 110 meters long. And the biggest difference is that we're shifting over to a container-based model. So we're moving away from the pallet and going to a container. Containers are more widely used, are kind of the industry standard. So we're kind of entering into operational efficiencies for our clients and with the existing infrastructures in the harbors. So we'll be able to transport roughly 200 TEUs, so 20 feet equivalent. Divide that by 2 if we were to put 40 feet. We are still, with these new rigging systems, able to be full sail powered. And we'll have over about 4,000 square meters of sales. And so what we're interested in is, yes, it's good to increase the size of or the dimensions of the ship, but you also have to maintain a favorable wind to weight ratio. So you have to have sufficient sails in order to actually propel the ship if you want to be a pure wind propelled vessel.
But can you dive a little deeper into a couple other technical aspects? Specifically, what type of sales system are you using? I know there's a lot out there. There's a lot of competitive sales systems, so I'm interested in that. And also, again, I caught your presentation last week when at Web Institute, and I understand that you have a system, a renewable energy system to power the onboard systems. Can you tell me a little bit more about that?
Absolutely. So obviously for us, it's important to reduce the carbon footprint of navigation in and of itself, and that's where the sales come in. And I'll come back on the technical choices of the sales in a minute. But we feel in order to have a really green project, you have to go a lot further. And the question of the hotel load or the onboard electronics and energy needs, obviously, we're not operating by candlelight on board. So you have some pretty significant needs for onboard energy, for satellite communications, for CCTV, for even all the hydraulic systems for your masts and sails. At this point, we're talking about pretty significant systems. We have electronic winches, electronic assist, we have autopilot, right? So all the modern day technologies, and that's also what we're always trying to do is kind of bring together the best of both worlds. We're certainly using ancient navigational techniques that we've been practicing for millennia, but doing it in a 21st century model. So trying to use the best of both worlds is always important for us. So that implies having energy needs on board. And the way we solve that is to utilize, first of all, two massive hydro generators. So these are propellers that spin reverse as the ship advances. So it's using the water current to generate friction and turn the propeller, and therefore we can capture that energy and store it in battery packs. And we also have a pretty significant solar panels all over the board, the deck, and different places. And with those two systems, we are capable, if we manage our energy needs properly, to have full autonomy and for energy purposes on board that are coming from renewable energy sources. So that's how we can really drastically reduce the overall carbon footprint. We do have generators, diesel powered generators on board as well for backup purposes if we need to. So we're not completely reliant on only renewable energies, but the objective is obviously to use that primarily. And one little thing that we did, we implemented that on Grain to Sell too, and that was the first time, as far as we know, that a wood pellet boiler was installed on a commercial vessel. So we're also using kind of innovative ways of trying to reduce the carbon footprint. Instead of using diesel fuel, we're using wood, and these are generally wood scraps that have been turned into wood pellets locally in France. So it's kind of a short circuit, a short circle of carbon. And then on Grain to Sell 3, what's rendered Grain to Sell 3 possible is the evolution in the rigging systems that, in particular, Chantier de l'Atlantique, which is a company based in Saint-Nazaire in France, have developed that is called solid sail. And solid sail is a different approach for the mast and the rig, where you no longer have cables connecting the top of the mast to the deck. So you're free to move your mast 90 degrees in either direction. And because it's a solid sail, that means you've got it's not a traditional kind of texture or a fabric that you would use on kind of traditional sailing. And these are more like panels. They look more like panels than traditional sails. And what really changed, so they've been working on this for the last few years now, and we've been in discussion with them for probably close to 5 years now. And their solution wasn't quite sufficiently mature and wasn't quite adapted to our programs. And now it's converging because the biggest advancement that they've made in the last few months is that this sail now is reefable. That means we can adjust the surface area of the sail and therefore adapt it to all wind conditions. And because the mast can rotate 90 degrees in either direction, we can also capture the wind wherever it's coming from. And so that's the biggest game changer. But now with Grain to Sell 3, that is a complete game changer, where you can have a 110-meter ship completely propelled by wind. And as I mentioned, having that favorable wind to weight ratio where you actually have sufficient surface area of the sails itself to propel the ship in all wind conditions and all wind directions.
For those watching, for those reading, all 99.9% of them who have never designed, built, or operated a sail cargo ship. Can you discuss some of the nuances that go into the design and construction of a sailing cargo ship? What, kind of a do and don'ts for those who may be interested in the concept?
Well, the first thing is that it's very important to consider the ship as a whole. So you have to design your hull, obviously, to try to optimize and reduce friction and everything that every basic naval architect is doing. But you have to do that keeping in mind that you're going to have a wind propulsion system on the deck. And the wind, in most directions, will generate drift because it's pretty rare that you're catching the wind from straight back. So it's usually coming at an angle, and that's creating drift. So you have to really think of the design holistically, and how are you going to prevent and correct the drift and allow for the wind to capture and generate forward momentum and not sideways momentum. Because if that's the case, then you're going to have to inevitably correct the drift, and most likely you'll be doing that with an engine. So you can't dissociate the two. And that's really the biggest thing. And so once you do that, then as I mentioned earlier, but for us, we believe that a wind propelled program must also accompany a carbon footprint reduction for the onboard energy as well. So those are kind of maybe the two biggest things. And consider that if, as of now, if wind is, if one of the limitations of wind is having smaller ships, then you have to be really, really good because of that ratio of CO2 emitted per ton per kilometer. That means that if you have major economies of scale, if you can transport a lot, you dilute the carbon footprint across so many more units. Whatever the unit may be, it's pounds or pallet or containers or tons, whatever it may be. But you're obviously, it's very interesting to have a lot of weight on board, given that metric. So if you have a smaller ship, you're obviously transporting less on board, which means that anytime you turn on the engine, your carbon footprint on a per weight unit is going to be much higher than you would expect it to be. So don't underestimate the negative impact of turning the engine on a small ship, even if you have a wind propulsion system. Now, that's on a relative value, of course. On absolute terms, you're probably using a whole lot less fuel than you would on a major container ship. But the metric in the industry is CO2 emitted per ton per kilometer. And so if you have less weight on board, be very careful about using the engine because the CO2 emissions are going to go way up. So to give you a perspective quickly, the best engines today are reaching 8 to 10 grams per ton per kilometer. And we're reducing that to less than 2, between 1 and 2 grams. That's where we get that 90% carbon footprint reduction.